Welcome to A-Level and AP Physics, a place where you can improve your understanding of physics with confidence. This is our second video on complex DC circuit problems from Cambridge AS Physics. In this video, we will explore more about complex DC circuits. This is our second complex DC circuit problem, and in this circuit we have four resistors and they are not identical resistors, mean their resistance is different. And a voltmeter is also connected in this circuit, and reading on this voltmeter is equal to 0, and this is very important point for us to answer this question. So what we need to find out, we simply need to find the equation for this setup. In order to answer this question, let's say this point is point A, and this point is B. This point is B. As it is given to us that reading on this voltmeter is 0, it simply means that the potential at point A is equal to potential at point B. Means the potential difference between point A and B is equal to 0. Simply, this is what we can conclude from here. Now, let's say current coming from this battery is I, and at this junction, current I will split into two parts. Let's say I1 is passing through resistor P and I2 is passing through resistor R. As the potential at this point is the same, and potential at A is equal to potential at B, we can also conclude that if we attach one voltmeter, let's say voltmeter 1 across resistor P, and we attach another voltmeter across resistor R, so the reading on voltmeter V1 has to be equal to V2. Another way of writing this one is we can say I1P has to be equal to I2R, and this is based on Ohm's law. Now we can rearrange this. We can say I1 over I2 has to be equal to R over P. Now let's move on to next resistor. Now next resistor is Q. The potential at this point are the same, and potential at this point is also same. So we can also attach another voltmeter across this resistor Q and another voltmeter across resistor S. From here we can also simply conclude that V3 has to be equal to V4. As you can see, there is no potential difference between A and B. It means the same current I1 is passing through Q and same current I2 is also passing through S. I2 means the same current through resistor R. So we can say I1 times Q is equal to I2 times S. From here we can rearrange, we can get I1 by I2. This will be equal to S over Q. So we can also say this equation, let's say this is equal to 1, and this one, let's say, is equal to 2. So as I1 over I2 is equal to R over P and I1 I2 is equal to S over Q, we can say that R over P is equal to S over Q. Now from here, if we simplify this one, we can get PS will be equal to Q times R. So this is our final answer. This is what question was asking us. So our answer for this question is D. So this is how we can find out. This is a little long actually method, but let me explain to you shortcut method. So this is actually kind of Wheatstone bridge circuit. This is Wheatstone bridge circuit. So if the reading on voltmeter is equal to 0, we can say Wheatstone bridge is balanced. So if this is true, Wheatstone bridge is balanced, then the ratio between this resistor and this resistor is always equal to the ratio between next two resistors, Q and S. Q over S. So then simply we can find our answer that PS will be equal to QR. So next time, simply if you can identify Wheatstone bridge circuit, and then if you can check is it balanced or not. If it is balanced, then simply you can use this ratio method and you can find your answer. This is a shortcut method.